Morning, good morning, friends. This is Srinath from the ECE section team. Today, I would like to explain you about the applications of an LED. Friends, do you know what is meant by a LED? Can you abbreviate the word LED? Yes, absolutely. Light emitting diode. We would like to know about what is the applications of the emitting diode. First, we need to know what is mean by LED. A light emitting diode is essentially a PN junction diode of semiconductor that emits a monochromatic means single color light which operates in a forward bias direction. LEDs converts electric energy into light energy. See here which is represented with the red color. You are all observing the red color bulb is that is the LED. The LED structure, the LED circuit is the LED structure and LED circuit is below the LED, red color. See, and the most important part of LED is the semiconductor chip located in the center of the bulb as known as the as shown at the right. See here, the chip has two regions separated by a junction. The LED is the LED is the semiconductor chip which is located in the center of the bulb. Means that is separated by a junction. Means that chip is separated by a junction. The junction acts as a barrier to the flow of electrons with the p and n type regions. Means where the junction is consisted with flow of electrons with respect to n type and p type semiconductors. And how does a LED works? How does light emitting diode which works? Each time an electron recombined with a positive charge, electric potential energy is converted into electromagnetic energy. This is the way the LED will work. And for each recombination of a negative and a positive charge, a quantum of electromagnetic energy is emitted in the form of a photon of light with a frequency characteristics of a semiconductor material. This is the way the LED will work. Here you can observe here, you can see there is a chip of LED and reflector and positive terminal and negative terminal which is p type and n type region. How much energy does an LED emit? The energy of a LED emitted by an LED is related to the electric charge of an electron and the voltage required to light the LED by the expression, that is E equals to QV, that is energy equals to charge per volume voltage is known as LED. This expression simply says that the voltage is proportional to the electric energy, where Q is the constant, which is electric charge of a single electron, that is minus 1.6 into 10 power minus 19 coulombs. Finding the energy from the voltage. Let us say that you have a red light and the voltage measured between the LEDs is 1.7 volts. So the energy required to the LED is E equals to QV. We all know that energy equals to minus 1.6 into 10 power minus 19 joules. Since a coulomb to volt is a joule, the product of these of numbers then gives E equals to 2.74 into 10 power minus 19 joules. See, what are the applications of LED? Our main topic is about applications of LED. Sensor applications, mobile applications, sign application, automotive uses, LED signals, illuminations, inductors. See, what are the sensor applications? Where does the sensor applications we can observe? It is used in the medical instrumentation, barcode readers, color and money sensors, encoders, optical switches, fiber optic communication. Mobile applications on mobile phone, PDS, digital camera, laptops, general backlighting. Sign applications is used in full color video, monochrome message boards, traffic traffic signals, transportation passenger information. And automotive application is interior lighting, exterior lighting, truck bus lighting. Means instrument panels and switches. Sign application where the signal applications is used. It is used in traffic, rail, aviation, tower lights, runway lights, emergency vehicle lighting. Means ambulance, that is the signals where these LEDs are uses. LEDs offer enormous benefits over traditional incantation lamps, including energy saving up to 85% less power than incandescent, reduction in maintenance cost, increased visibility in daylight and adverse weather condition. See colors of LED. What are the colors of LED which is included? LEDs are made from gallium based crystals that contain one or more additional materials such as phosphorus to produce a distinct color. Different LED chip technologies emit light in specific region of the visible light spectrum and produce different intensity levels. See, when LEDs are available in red, orange, amber, red, orange, amber, yellow, green, blue, and white. These are the colors of an LED. Where tricolor LEDs, you may also see some LEDs which is consist with tricolors. That are the most popular type of tricolor LED as a red and green LED combination in one package with three leads. There are different lengths of three leads. You can also see the bicolor LEDs. A bicolor LED has two LEDs wide in inverse parallel and combined in one package with two leads. Only one of the leads can be lit at one time, and they are less useful than the tricolor LEDs. LED performance. All this LED performance is based on a few primary characteristics that are color, white light, intensity of the light, eye safety information, visibility, operating life, voltage, design current. These are the ways. See here there are the depth. How the color is used. Peak wavelength is a function of the LED chip material, although process variations are plus or minus 10 nanometers. The 565 to 600 nanometers wavelength spectral region is where the sensitivity level of the human eye is highest. Therefore, it is easier to pursue color variations in yellow and amber LEDs than other colors. And in white light, how this white light performs in LED. When light from all parts of the visible spectrum overlap one another, the additive mixture of colors appears white. Primary colors from the upper, middle, and lower parts of the spectrum, red, green, and blue, when combined appear white. Eye safety. While using the LED, we can't flow the LED glow on our eye because the need to place eye safety labeling on LED products is dependent upon the product design and the application. Only a few LEDs produce sufficient intensity to require eye safety labeling. See visibility. How this LED performances. See, you can also see luminous intensity does not represent the total light output from an LED. Both the luminous intensity and the time radiation pattern must be taken into account. See here single chip LED. This is 6 chip LED and this is 7 chip LED, and this is lensoid LED cluster. Means there are different types of LED that radiation and visibility that doesn't intensity doesn't wants to perform on us. This is the way. Operating life. Operating life. LEDs are designed to operate upwards of 100,000 hours at 25 degrees Celsius ambient temperature. When the LED degrades to half of its original intensity after 1 lakh hours, it ends of its usual life term. The LED will continue to see here some types of LED: bar graph LED, 7 segment LED, star burst, dot matrix LED. These are the some other types of LEDs which we can perform the LEDs. Means I know all of you, thank you for giving this opportunity. See, I think most of the